I'm CK. Tonight we have another module from Frequency Central, their State 700, a Roland similar filter system. We'll put it together, see how it goes together. Should go together pretty well. It's a Frequency Central build. And see how it sounds. Hope you enjoy the video. Here's the box from Frequency Central. I purchased it through Thonk, both from the UK. See what's inside. Power cable. This looks like the board and front panel, probably, in a nice paper bag so it's easy to recycle. Audio in, looks like three jacks, pots for the levels for audio in, I guess. Frequency, response, resonance, then CV, 3 pots, 3 inputs, and here's the output, high pass, band pass, and low pass. It's kind of wide, isn't it? Wider than many filters. So here's the jacks and pots board. Looks good. All through-hole plated, as is typical from Frequency Central. Values are all marked on the board. Bunch of resistors on the board as well as the pots. Design Rick Holt, PCB Johnson Dunn. And here's the logic side. Tons of resistors. An LM3700 and 3 TL072 op amps. Oh, that's interesting. There's 2 trimmers here, labeled offset 1 volt per octave, which is typically what you see on a VCO. We'll see what we're trimming up there, probably the CV in for frequency, maybe CV in for resonance, but probably CV in for, again, I'm not sure what this CV in drives. So we'll find that out. I obviously have not read any of the material that comes with the book. I mean with the kit, because that's the kind of guy I am. We'll open this bag first, because it's got the most stuff in it, it feels like. One thing with paper bags, you do have to look inside, make sure you haven't missed anything. Now they've mixed some mechanical stuff with electronic stuff, so I'm gonna toss all the jacks into this other bin so they're not in the way, jacks and pots, because we'll be dealing with all those later. Knobs are okay, brass set screws. There's no metal backing, so the brass threads are going right into the plastic, so just be careful that you don't tighten them too much and strip the plastic. Rest of the jacks, get them out of the way. Some big foil caps, some electrolytics, the chips kind of floating loose and around. I'll grab a piece of foam that has a bug on it. I'll grab a piece of foam and secure these so they don't get their pins bent, or potentially any electrostatic issues, even though I've been in the electronics business for a very long time, and I have tried to shock chips, and I've never successfully damaged a chip with static electricity. But it's a good idea to be careful anyway. So that's all stuff for later. This is all stuff that'll go on the board. Oh look, one of those pins is already up out of this socket. It'll be fine. Pins are a little bent. Let me get my needle nose to line them all up so they're all parallel. Look at the other sockets. Yep, another bent pin. That one's okay. Okay, so that's that bit of electronics. Going a bunch of, I bet these are 104s. No, they're not. They're 47 pico. Huh. Oh no, 47 nano. Or 470 nano. I'm sorry, I keep saying the wrong thing. 470 pico. Gosh darn it. Again, 4, 7, and 1. 4, 7, 1, 0, 470 picofarad. If you're learning at home. Here's a bunch of resistors. I think this whole bag is probably resistors as I look at the circuit board. Yeah, it is. It's all resistors and 2 diodes. And one thing that Frequency Central does that's thoughtful is they put the value of the resistors on the paper tape. For those of you who are not as proficient in reading resistor bands, and in 2022 you don't need to be. You have many tools to help you. You don't have to memorize that stuff anymore. In fact, if you want, you can look on my channel and you'll see a build of this, which is a little calculator kit, but one of the good things, fun things about it is it's got a resistor color ring calculator, so we can see this is brown, brown, black. What's the value? Because then I'll know. Green, brown, so that's brown, brown, black. Oh, I'm reading it the wrong way, sorry. It's the only problem with brown, green, black, brown, brown. So it's a 1500 1.5K at 1% tolerance. So this is a handy little thing. The other thing that it actually is, let's see, where does that go anyway? It's the 1K5s here. The other thing that this calculator, even when you don't have it turned on, you can figure out the colors, the values anyway, because black is 0, brown is 1, red is 2, orange is 3, 4, 5, and so on. So it's a cheat sheet for the colors even when it's not being used as a calculator, which is kind of neat. Okay, so that's it. Nothing too surprising. Looks like a pretty straightforward build. Just a lot of resistors to put on the board. So I'll get the soldering iron heated up and we'll dive into that. We can actually go ahead and put all the resistors on the board as the first thing we're going to do. And again, as I said, there are a metric ton of them. Not really, but exaggeration is fun. We'll do the 100Ks first. Now just a little, in the case when somebody does give you a little indication of what value they are, just put it there so you don't forget, because you can. I mean, I've gotten in the middle of putting together a raft of resistors and saying, what value are these again? And having to look on the resistor and figure it out again. So just leave the little piece of paper there. I'm going to do this board first because it's got 400Ks on it. I'll just get them out of the way. And we'll look at one. And first thing, interesting thing to check is how much lead, or how far from the body of the resistor do you have to bend the lead. And this, you probably have to bend it a millimeter. Oops, I put it in a 47K hole. You have to bend it out from the body by about a millimeter So you don't want it to be, you don't want to bend the leads right up against the body of the resistor. So now we know that. And the next thing is, how does the solder flow on this board into these solder holes? The solder holes are a little bigger than many other boards. So we'll see, and flows really nicely. And we'll look at the other side, because with through-hole plated boards, you can see the solder wicking up through the solder hole, which fully encompasses the lead, which is very nice. You're never going to get a cold solder joint with that. That's why I always look for through-hole soldered boards. Now, all the rest of the resistors are pretty much the same. Not much to talk about with them. And that means I'm going to put all 20 or so resistors on with no commentary, and I'll put the cameras in fast playback mode, or actually I'll playback the video in fast motion. So enjoy resistor time. And there's all the resistors on both boards. Let's get the two 4148 diodes on. They're not power protection, they're for other nefarious purposes. Always double check your diodes, because it's just irritating when you get them wrong, and it's easy to get them wrong if you're going fast. So now we'll put the ceramic caps in. This is the 470 Pico. Those here. And when you look at these little guys, the little disc caps, the 470s, and often the 1/10 of a microfarad 104s, and you're wondering where they go, always look near a integrated circuit. They're often placed near integrated circuits as a buffering, power conditioning, whatever, however you want to describe it, ensuring that power going to the chip is smooth. Now we've got a 10K and a 100K trimmer, and this is 103, which is 1 0 and 3 more zeros, so that's the 10K. And the 100K is 1 0 with 4 more zeros, and that of course is 100K. I think I'll go ahead and solder them down. I often don't do those immediately because the legs have enough bend to hold it firmly in the circuit board hole. But these felt a little loose. As I mentioned, the holes on this circuit board are a little bit bigger by, a couple of mils, but it's noticeable. Now, I think before I put the electrolytic caps on, we'll put all the IC sockets on. Notch on the socket to notch on the board, and this was the one I had to fiddle with pins, but it went in fine. So rest the socket on my pinky finger behind the board. Solder one pin. Let it cool and flip it over and make sure everything is aligned and flat on the board. It is. And when I say let it cool, I mean let it cool naturally. Don't ever blow on a solder joint to cool it. That creates uneven cooling and can make for a bad solder joint. So even if you're tempted, see now that's not flat. So what I'm going to do is push on it with my index finger now, reheat that pin, and it settles onto the board really well. You do not want to blow on solder joints to cool them off. There's another YouTuber who does a lot of guitar amps, which I also do. I don't do videos of those because it's so long. I don't know if anybody wants to see a video of me building or repairing a guitar amp, let me know and I'll put it in the rotation, but it's such a long time. But as I was saying, there's one YouTuber who I didn't know what was going on. I was watching his videos and I kept hearing a noise, and I realized he blew on each solder joint after he soldered it. I finally had to stop watching him. It was so distracting to me. Okay, we'll solder all these joints. And that's all of those. Now we'll do the foils here, and instead of fighting them out of the tape, I just nip the leads off. No need to fight. And now the electrolytics, and we've got what? Okay, we've got 4. We've got 5, and we've got 1, 2, 3, 4, 5. Okay, 10 microfarad and 22 microfarad. Come on, Spider. You're not helping the process. And again, square pad and a plus sign for the long lead. It's a lot of buffering. This is a lot of electrolytic caps for a eurorack board. There are 2 different types of transistors on the board. There's an NPN and a PNP, and the numbers are very close together. The NPN is BC547, the PNP is BC557. Make sure you get them right, or you will be sad. Probably says that in the build guide, which I didn't ever bring up, did I? Because my water heater went on and distracted me. Now we'll put the power connector on, and this is a keyed power connector. So the power cord can only go in a particular way, and the red stripe is down, and the red stripe negative 12 volt line is down on the board, so we know exactly how it goes on. Always check with an actual power cord. Doesn't take much extra time, a couple of seconds, but it will ensure that you get it right. Okay, next step will be to cut up and put on the pin headers that are going to connect the 2 boards. Now, how do they go? Well, let's think about it. The power connector has to hang off the back here, and the knobs and pots have to stick out the front here, which means the 2 boards are going to mate like that. And I think I'll put the female headers on the logic board and the male headers on the other board, for no other reason than just because. I got to get a different pair of pliers to cut the female header. Going over to toolbox number 2 to get that. And as always with female pin headers, you will be sacrificing 1 pin when you cut them apart. Can't be helped. But as you can see, there were 2 extra pins on this strip of pin headers. If you're going to buy spare parts for your electronics bench and you're doing eurorack stuff, I would recommend the first thing, if you're starting a stockpile, get a bunch of pin headers, male and female. Because if you make a mistake, nothing worse than making a mistake and saying I don't have a spare pin header. That's those pin headers. And I guess I will clip this off just cause. Now we'll do the same thing with the male pin headers. But I won't need those pliers, I can use my regular ones. So this board is done, and I'm going to go ahead and put the ICs in their sockets. Making sure the notches are correct. And again, as I always say, the notches on the sockets are nice, but the notch silk screen on the circuit board is what matters. So always look past the socket to make sure you've got the notch right. I hope that went in well. This pin is a little kicked out. Let me see if I have continuity on that. Bring my meter over, set it up for continuity. Take the alligator clips off the end. Make sure it beeps. Beep. So I'm going to go to that pin there, and I'm going to go to the other side. Yeah, we got good conductivity. The rest of these, just double checking that they're all 072s, just to make sure someone didn't make a packing mistake. Things like that happen. I'm going to pull this LM3700 back off. It's not sitting in there right. Ouch! That happens. Drove a pin into my finger. Let me straighten all the pins out again and make sure we got good alignment, because that one really was not aligned right at all. So I'll just dress the pins up a little bit. But again, because I just did that, I'm gonna go ahead and check continuity on all the pins. Just because I want to be triple sure. And it takes just a couple of minutes. Okay, it's all good. Taking a couple of minutes to be sure is better than watching things either blow up or not work. And one more time on this one, just because I didn't like the way this side went in, really. And there's the electronics board. Now, what I'm going to do is what I do as a habit of mine, is I'm going to take my index card and I'm going to go by, look at all the solder joints on the board, one row at a time, to make sure they're all soldered, number one, and number two, to make sure there's no bridging or ugly looking solder joints that aren't shiny, for example, that haven't cooled evenly. And they all look good. Now it's time to put all the controls on the front board. Now remember, all the pots are not the same. Be sure you've got your B's and your B taper and your A taper in the right locations. Again, it's technically, the nuts are still on these. I didn't take them off. Now, usually it'll still work if you put the wrong taper in a position, but the response will be kind of wacky. You'll say, why is it doing that? And I'm finally looking at the build guide because I want to see which pots go where. Okay. So I was not putting them on right. We want the two green base, the beefy ones, in the middle, and then the blue lighter weight ones at the top and bottom. I'm missing a pot. I'm going to turn the cameras off and see where this pot went to. There were probably some of you who were yelling at the screen, "It's under the circuit board, you idiot!" And it was. I always like to put the pots on first, switches, if there are any, on second, and then jacks on third. Just a habit. Pots on first, simply because with the little locking bend on the support legs, that can make the circuit board jerk. And if the circuit board jerks, then experience has taught me the jacks will all pop out and you have to do the jacks again. So may as well just do the jacks once by putting the pots on first. Same with switches. Some switches have legs that are very big and barely fit in the circuit board holes. Okay, now we'll gently put the front panel on. Use our pointy thing to align all the jacks. That's all on. I'm going to take one of the pot panel nuts and screw that down. So it will keep everything in place as long as you don't shake it too hard. And now we'll solder up all these connections. Now, same thing on this board. I'm going to go back and look at each solder joint. And you may have noticed I used thicker solder for the lugs and big pads on the jacks, just because it was faster. Now put all the panel nuts on. And for some reason or other, I have an extra jack panel nut. That doesn't make any sense, but it's true. Let's see what we got here. These are slot head. Now we'll put the two knobs on. Make sure it's fully counterclockwise. Aim it right there. And of course the other pot's in the way. Now I'm going to put the power cord on the back board, the main logic board. Now we're going to mate the boards. And there we go. That's the front. It's the side. It's the back. The other side. The top. And the bottom. Now we'll put it in the rack and see how it sounds. Alright, we're going to we've got it in the rack, we've got it running. And I apologize for the rat's nest, but we're coming from the Division 6 sequencer, the Even VCO, the More VCAs, a Duskworks VCO, LFO, my multi, so I can repeat all these things so I can have two inputs. So it got a little complicated. First thing we're going to do is trim out the VCO, the volts per octave trimmer. So we turn the resonance all the way to self-resonating. And there you can hear it a little bit. And we have the tuner app up, so we'll see whether we're not quite right. I'm going to mess with the octave trimmer, which I forget which one that is. Well, that's within 1 cent of being perfect. I mean, actually, it's not 1 cent. It's within about 3 cents of being perfect, so I'm not going to mess with it. Offset trimmer, you want to tweak this so the filter is fully open when the cutoff pot is fully clockwise. Okay, so we'll take resonance back out and we'll put the cutoff in and we'll hear what it sounds like. Yeah, that sounds good. Let's take it back out. Now we'll go ahead and put it through its paces. So this is, again, with one input currently, and as you can see on the scope, it's a relatively flat. Now we'll bring in some filtering. This is on we're coming out through the high pass, and I've got the mod all the way down too. And that's all the way up. I'm going to go to band pass. Now we'll go to low pass, which may not be much on this one. I'll turn up the volume a little bit more. So that sounds kind of neat. I'm going to go back to band pass. Now we'll bring in some resonance. You can see the waveform starting to change. That's resonance all the way up. That sounds really good. I'm going to put the LFO into the mod for one. So that sounds pretty good. I'm going to bring in the other oscillator now. Take out number one so you can see it. Now we'll bring them both up. Put the mod in OS2. So that works pretty well. I'm going to go ahead and put it on the sequencer. Both inputs are fully up now. Put a different waveform in a sine wave, actually saw wave into mod for 1. Now we'll go back to high pass. Now we'll go back to low pass. And I'll pull the LFO out. As you notice, there's a lot of volume change as the modification goes in for resonance, so you have to be careful with that. So that's what it does. It sounds pretty good. It's a good filter, got some sweet resonance, and the low pass side can sound pretty beefy too. And as you saw, a pretty straightforward build, pretty quick. Another good one from Frequency Central. I hope you enjoyed the video.